Hello, viewers. It's been a while. Today, we want to talk about the equations of a straight line. Just like you can see on the screen, we have three different equations, but all of these three are equations of a straight line. They are so very easy to use. Why do we need to talk about equations of a straight line? We are still trying to use mathematics to describe the real world. And in the real world, there is something you talk about correlation. When two things are proportional to each other, that means as one changes, the other one also changes correspondingly. There's something that is correlating those two things. So, whenever you talk about proportionality or you talk about correlation, then equations of straight line come into play. In the first equation, we have that y is equals mx plus b. In that equation, b there represents what you call the intercept. Normally we have the y and the x-axis. Now the point where the line crosses the y-axis is called the intercept, and that is what B represents. M there represents what is called the slope or the gradient. Let us use a simple graph to represent this concept. So here we have some simple graphs. Here I have the y-axis and then the x-axis. The y-axis is the vertical axis. We are talking about up, down. That is the y-axis. And then we are talking about from left to right, the horizontal. This one, that is the x-axis. In all four graphs, we have y-axis and we have x-axis. Now, in all of these four graphs, we have a line demarcated by this red line, a straight line. So, for this straight line, there is a point where the line crosses the y-axis. You can see this one here, it crosses or it touches the y-axis. Because it is a straight line, it will keep on going up or down. One thing you will notice about these four different graphs is that there is a particular point where the graph touches the y-axis. In this simple sketch, we try to make it that point to be the +1y. Let me illustrate what we're trying to do. I hope we all still remember the number line. That number line where you have numbers numbering from left to right. Negative numbers starting from 0. That point is 0, so you have negative numbers there. And then points to the right are +1, +2, +3, +4, while points to the left are -1, -2, -3, -4, on and on like that. So that's the same way that we number the graph as well, using the concept of the number line. The center where both y-axis and the x-axis touches is 0. Now, when you are numbering to the right, you have positive numbers 1, 2, 3, 4. So that's the x-axis. Then when you are numbering from 0 to the left, you have -1. The next point will be -2, -3, -4. Because of space, I didn't put all the negative numbers, but that's the concept. The same way when you're numbering the y-axis, you have 1, 2, 3, 4, 5, 4 points going up, but coming down from the 0 point, you have -1, and this is -2, -3, -4, -5, -6. I didn't indicate all the numbers because of how small the graph is, but I'm sure you can get it. So one thing you can notice from all of these graphs is that the different lines, they have different slopes, what you call different gradients. A slope is referring to how steep you're going up and down, the angle of your going up and down, how steep it is. That is the gradient. I don't know of a simpler word that I can use, but think of when you are climbing a staircase. You know, some staircases, I mean, it is very steep when you are going up or you are going down, while some are very mild. They made the steps such that even a young person or an old person can climb gradually. So such steps where you can climb gradually, they are said to have a milder slope or less slope compared to those ones where it is very steep as you are going up and down. So that concept, that idea of how steep it is called the gradient, and it is very, very important concept when we are talking about a straight line. We are trying to determine this straight line. Assuming I have another straight line like this, it will be called parallel to the x-axis. I mean, it is moving straight from the left axis to the right axis. It will be called parallel. But as long as it tilts a little, it tilts upwards a little from this x-axis, then it has a slope. So one of the concepts of the straight line is that of the equations of a straight line is that for any line that we are given, we try to determine the slope of the straight line. We also try to determine where that straight line cuts either the y-axis or the x-axis. So let's use one or two examples to illustrate these concepts. So here I have another graph because we're finding it difficult to number our x and y axis because we want to blow this up for the camera. In this graph, instead of one box representing one unit on the x and the y axis like we did in the other graph, I've decided that okay, let two boxes represent one unit. So you count here 1, 2, that is 1, 1, 2, another one, making 2, 1, 2. The same thing on the y-axis. It doesn't really matter. You using the graph are to determine how many boxes will represent one unit. So in this one, I have determined that two boxes will represent one unit. If you are using your normal graph, this is the same concept. Now, one thing we're going to do on this line that is given to us is that we are going to determine the slope or the m in this case. You can see these graphs, these equations of the straight line. You want to determine m. It's very, very important. Now, to determine the slope of this graph, it's very easy. Look at what I'm going to do. So look at this other smaller equation here that I have here. M simply refers to the rise over the run. And what do we mean rise over run? It means that as you are moving on the y-axis, the change in the y-axis is referred to the rise, while the change in the x-axis is referred to as the run. So with that concept in mind, whenever we are given any graph like this, and we're saying the first thing is to determine the slope of the graph. Now, you just take any 2 points. Just take any 2 points of the graph. And those 2 points, you project those 2 points down. So I have taken this point of this graph, I have taken this point, I will project it down, and then I will project it back. So I have taken both this point and this point of this graph. I will project it vertically and I will project horizontally to where both of those points meet. And I will try to determine those numbers. Look at, for example, in the slope of the graph that we drew, we said the slope is rise over run. I hope you are with me, that the slope is the same thing as the m, is the same thing as the gradient, is equals to the rise over the run, and it is the change in the y, that is y2 minus y1 all over x2 minus x1. So with that in mind, don't get confused. It's very, very easy. We are talking about the change in y. That means as you move up and down, that is the change in y. That is y2 minus y1. Now, in this graph, it cuts the y-axis in 2 points. Look at it. If you project this down, it cuts the y-axis in 2 points. So this is y2 and this is y1. Did you get it? So y2 here is 3. Our y2, this point where these 2 points that we have chosen, our y2 is 3 and our y1 is 1. All over the x2, you project this down again. Now, where does it cut the x-axis? It cuts the x-axis at, hang on. I made a mistake earlier. Our 4 is supposed to be here, not here, because I'm taking 2 units to be equals 1 on the x-axis. So 1, 2, 1, 1, 2, 2, 1, 2, 3, and 1, 2, 4. So our 4 is supposed to be here, rather. So this point that we have chosen cuts the x-axis at our x2 is 4. Did you get that? Our x2 is 4 and our x1 at this point, remember, this is 0 minus 0. Yes, because this is our 0 point. So these are the 2 points where it cuts the x-axis and the y-axis. So what is 3 minus 1 is 2 and 4 minus 0 is 4. That we can reduce this. Remember the rules of fraction, you divide both sides by 2. It's equals 1 over 2. So this is our graph. It is half. If the rise is 1 step, the run is 2 steps. And it is positive. There is no negative sign here. So that simply tells us that the slope of this graph is not a very steep slope, or the sloping of the graph is not very steep. That is what this figure tells us. We're going to use another example to drive home this point. So here we are having another line, again on the x and the y axis, and then instead of sloping up, what you can notice is that this line is sloping down. This is the slope that I'm telling you about. Instead of it sloping up on the xy axis, this line is rather sloping down. So again, we just choose 2 points on the line to determine what the actual slope or the gradient is. I have decided to choose these 2 points, any 2 arbitrary points. So these are the points that I have chosen. And all I need to do is to project these points to meet each other. And this is how I project these 2 points to meet each other. Very easy. Now I am going to determine the slope of this graph. Remember that the slope is rise over run and is equals y2 minus y1 all over x2 minus x1. So for these 2 points that I've chosen to determine the slope or the gradient of this graph, what is y2? Our y2 is minus 3, as you can see. This is minus 3. Minus our y1 is 1. All over our x2. Of course, I still have to project these 2 points to meet the x line. So our x2 is 2.5. Let me put it in fraction form. It's 2.5, while our x1 is 0.5. This is 0. This is, if this is 1, then this is 0.5. So 0.5 is half minus half. Oh, we're gonna have some fractions here. That makes it interesting. Minus 3 minus 1 is minus 4 all over. We're going to convert this to improper fraction. So use this to multiply this. 2 plus 1, that's 5 over 2 minus half. I hope we can see what we're doing. All right, so this is where we were, that our slope is equals minus 3 minus 1 all over 2.5 minus half. I just decided to move this to a plain sheet so that it will be easier for us to solve. Now, minus 3 minus 1 is the same thing as minus 4 all over 2.5. We said let's convert this to improper fractions. In this example, you are going to see why fractions are very important. Improper fractions, you use this to multiply 2. 2 times 2, that's 4, plus 1, that's 5, all over 2 minus 1 over 2. Now, I am going to solve the denominator first. I'm going to solve the denominator first, so that gives me, let me just leave this minus 4 up there. There are 2 fractions here in the denominator, so you can see they are like fractions rather, because they have the same denominator. So you just bring down that common denominator, and then the numerators of those 2 fractions will give you 5 minus 1 is equals minus 4 is still there. 5 minus 1 is 4 all over 2. And what we're having here is the same thing as minus 4 divided by 4 over 2. All I need to do at this point is to change this side to a fraction. So I'll say minus 4 over 1. Remember, this was the numerator. We have not done anything to it. Minus 4 is the same thing as minus 4 over 1. And we have also learned how to solve this. We just need to change this sign. That becomes minus 4 over 1. And when we are changing from division to multiplication, it now becomes, instead of 4 over 2, we invert, or we flip, and it now becomes 2 over 4. And then at this point, we just cancel out. 4 can cancel 4. 4 will cancel 4. And what is remaining in that place, in the numerator rather, will be equals minus 2 all over 1. Minus 2 over 1. So that's the answer. So let's just bring it back to our graph. We have said that the slope is equals minus 2 over 1. And notice one thing. We solved it and this minus is there. What is that minus telling you? That minus is telling you that the graph is, the straight line rather, is bending downwards. Unlike in the other case where the graph was curving upwards, this time around the straight line is curving downwards. And there is something rather interesting about these two graphs that we had in this example. I mean, this wasn't planned, it was just coincidental. We have seen that in our first graph, the slope was 1 over 2, while in the second graph, the slope is minus 2 over 1. So similar results, but that negative there tells you that the direction of this line is curving downwards, while the direction of the first graph is curving upwards. You can see how interesting these things can be, guys. So, I mean, this is one of the basic foundations of equations of a straight line. You need to know how to be able to calculate the gradient or the slope from the graph. And in our first graph, just merely looking at it, you will know that the graph cuts the y-axis at 1, while in the second graph, it cuts the y-axis at 2. So that is also another very important concept that we are going to explore in the next video, because the point where the graph cuts the y-axis or the y-intercept is very, very important. Guys, I hope this was interesting, and I hope I tried to make it simple enough. Please share this video, please comment, follow this page, and please invite others to follow this page. Our goal here is to make learning as simple as possible. Bye-bye. I'll see you in the next video.